Hi, my name is Diego and I'm presenting this tool of Terra Antiqua. It's called Create Topo Bathymetry. In this video, you will see a summary of the tool's functionality, the user interface and the dedicated page in the manual, step-by-step indications, and some final considerations and important parameters. In the Terra Antiqua YouTube channel, you can find similar videos for the other tools. They are also accessible from the manual. Create Topo Bathymetry is a primary tool. This means it's part of the main reconstruction workflow. It works together with another primary tool called Modify Topo Bathymetry. Both are meant to edit the topography or bathymetry in given areas that you have to define. Then, these tools allow you to concentrate on those areas of interest and edit the local topography or bathymetry with precision. The order in which you use these tools is up to you. Here, I will work with Create Topo Bathymetry. There is another video dedicated to Modify Topo Bathymetry. The link is in the description and in the manual. Click on the icon of the tool and this dialog pops up. The text on the right will help you understand the parameters. It has detailed information about everything you see here. On the left, there are combo boxes for the input files and different parameters. If you click Help on the lower left-hand corner, you will go to the manual. This is a static website with all the documentation about Terra Antiqua and step-by-step indications for each tool. Here you have all the info about the tools, technical details, warnings, and even guiding tips. It works as a complement of the help text in the tools dialog that I showed before. This is the page for Create Topo Bathymetry. For the rest of the video, I will follow the step-by-step indications. Feel free to pause this video at any moment and take your time to read these paragraphs and the help text on the tool, since they are much more detailed and include specific recommendations. You will notice that this page has a banner. It means that there are different versions of this tool. There is more than one functional version of Terra Antiqua, so for the tools that have been upgraded, there is documentation corresponding not only to the most recent version, but also to the older ones. Here I'm using version 1.1. Let me remind you that this tool is complementary to Modify Topo Bathymetry, so they can be used before, after, or instead of each other. This tool is useful to create new topography or bathymetry in regions that are too different from the present-day geography to simply rescale them. With this method, the pixel values for the area will be erased and a mountain range or ocean basin will be created from scratch. The first thing you need is the input data. This consists of the compiled DEM with the right paleoshorelines and a set of polygons marking the areas where you want to create the new feature. Here, I will use files that are ready from Terra Antiqua's sample data bundle for a global 30 MA reconstruction. It's available for download from the manual website. Each of these 4 files contains a polygon for a region that cannot be simply rescaled and where I will have to generate a mountain range from scratch: the Tibet, the Andes, Ethiopia, and the Cordillera Darwin. This other file with 2 polygons is there to create an oceanic region between India and Asia corresponding to the Greater Indian Basin theory. We will see it later. First, let's create the High Andes region as an example. Once the input files are selected, you have to define the parameters for the new mountain range: maximum and minimum elevation, ruggedness, width of the mountain slope. Have a look at the help text here on the right to see what this means exactly. You may pause the video now and take your time to read the description of these parameters. Go ahead and try different configurations until you're happy with the result. If you have data about the elevation values, use it here. The best way to work with this tool is trial and error to see which settings give the best result. If the shapefile you're using contains more than one polygon and you don't want to use the same parameters for all of them, you can set different values for the parameters in the attribute table and then choose the option to retrieve the data from that attribute table. In this file, from the sample data bundle, the attribute table is already filled with data extracted from the literature. You can either define an output file path or use a default one which will create a file in the temporary folder of your system. This is the result with the Central Andes region reconstructed. Now let's try to create some bathymetry. This file contains 2 polygons, so I will have to use this option to take only one of them. For this, I have to select it first and then open the tool again. Now let's fill the parameters for Cs: maximum and minimum depth, maximum shelf depth, shelf width, and width of the continental slope. See the help text for the description of each parameter. Again, we recommend you to try different configurations and see which one represents better the bathymetry you want to create. Since I'm creating an ocean basin linked to an existing one, this option will make sure they're integrated. The help text on the right explains what this option does, and there is more detail in the manual. Once more, take your time to see what keep deeper bathymetry or keep higher topography mean. You can either define an output file path or use a default one which will create a file in the temporary folder of your system. This is the result. Since I used the raster with the Andes, now both features are on the same map, the High Andes region and the Greater Indian Basin. The sample data bundle for 30 EMA has other regions where you can try this too: Tibet, Cordillera Darwin, and Ethiopia. Feel free to try out different parameters there to get familiar with this. Finally, I wanted to stress that this tool is designed to be used in combination with modified Topo bathymetry. And there is another video showing a practical example of how these tools can work together, explaining why we use each of them in the different regions. There's a link at the end of this video and in the description.